Am I audible? Is my slide is visible to all of you?
Yes, sir. Slides also visiting, sir. You also audible, sir.
Thank you. On this gracious occasion, I thank the respected organizers. Uh, my name is Ravi Kiran. I am working as a lecturer as a CERTOL in Department of Mining Engineering, University College, Kottagudem. In this session, I am going to discuss a brief brief introduction and how modeling as of now regarding substance is going on in mining stream. Regarding these things, I wanted to give a brief introduction uh, without wasting any time. Okay, as you all know, substance is nothing but it is a it is nothing but the uh, depression that is happened because on the surface it may be naturally occurred it may be natural occurring phenomenon or because of the man-made activity. There are basically there are majorly there are two types of substance phenomenon. There are natural phenomenon and man-made phenomenon. In natural phenomenon, what we will consider is the substance which is caused due to the natural activities like earthquakes, tectonic plates that are moving in the earth's crust. And the crust activity means if at all any soluble minerals or groundwater, because of the groundwater movement, some soluble minerals may like sandstone or calcite like these deposits, they may deform and they may cause naturally these type of substance is called as natural substance. And the man-made substance can be termed with reference to the mining induced substance. And the groundwater after the extraction of groundwater, because of the void, it may tend to create a it may tend to form substance, as well as with the removal of the soluble minerals like oil or petroleum removal or natural gas removal, or in some cases because of the geothermal power production. In some cases, these substance may tend to cause these things will come under man-made activities. This is a rough representation of these things with reference to natural and gas activity, mining activity, dissolution of limestone and groundwater. Basically, initially the surface may be like this because after the activity, it may tend to form in this the first table. First column will give the natural initial activity. Because of this disturbance or because of these activities, the surface may be deformed because of in this formula. With reference to our program today, my main motive is with reference to mine subsidence. As we all know, the mining activity is nothing but the removal of the removal of the material from superincumbent strata. Because of the extraction of material from the superincumbent strata, the the stability of the soil, the stability of the surface may tend to be uh, disturbed because of because of the natural stresses and the induced stresses which are acting on that particular surface. Because of this particular thing, the surface may gradually or suddenly sink downwards, causing subsidence. This particular phenomenon is termed to be our mind subsidence. This is the pictographical representation of our mind substance. Below here, this particular black color phenomenon is an with reference to a coal bed. In this particular thing, we are extracting the material, either any type of activity, any type of method. If you are removing the material from the surface as the day progresses, because of the stress and because of the different types of forces, it may tend to be slowly moving downwards, thereby causing the surface to deform. This particular as this particular S represents the maximum possible subsidence. As I told earlier, the surface may tend to move from surface to the underground. So broadly, it can be termed as a vertical displacement of the surface from top to bottom, or from natural surface to downward. With reference to these particular things, there are some components, or there are some terms which will be with reference to the substance. These are the basic terms related to our substance. As I told earlier, vertical displacement means nothing but the naturally downward declinant of the surface because of the movement. Horizontal displacement means as we pictographical in this particular thing, pictographically we can see this material is coming from surface to the underground. But how the horizontal how the horizontal displacement is important means, because on surface we have different types of flora and fauna, different types of plants. Naturally, the plants which are on the surface may tend to, uh, because of the material deformation, or because of the different activities, with reference to a particular drawing, I will explain. Kindly excuse me, my system is bit hanging. Okay, in the meanwhile, as I told earlier, the horizontal displacement, and the thing is the slope. Matlab, uh, the relativity with vertical and horizontal displacement, the material may tend to slide downwards. This particular thing will be termed as the slope of the subsidence. With reference to the horizontal displacement, the as we all know, strain is nothing but difference in change in the displacement to the original displacement, which will be with reference to our horizontal, with reference to our mining condition, we will take it as mm per meter, or centimeter per meter. The positive thing which in this particular strain will be termed as a tensile strain. The negative term will be termed as a compressive strain. The tensile and compressive strain have a major effect with reference to our subsidence, because with reference to the new Forest Act in 1986, what they have made was, if our horizontal strain or the tensile strain, if the value is between 0 to 5 per meter, it will be termed as a safe mining activity. If our displacement is between, if our strain is between 5 to 5 to 10 the amount, the before starting of the mine, we have to pay some amount as and to the to get environment clearance. That particular amount, they will take a 10 they will deduct a 24 25, they will deduct a 25% and give us 75 amount. If our strain is between 10 to 10 to 15 there was a deduction of 50%. If our strain is more than 20 we have to totally forget the ECA the amount which you have placed there. So as of now, the strain component is playing an important role with reference to our subsidence phenomenon. And with basically those are the different types of different components of subsidence. But with reference to the mining activity, there are some factors that influence subsidence. As we all know, if we are removing a single layer of single layer of material, the thickness of that particular material will also have a drastic effect. So the seam thickness, multi seams means if there are several layers. uh, Suppose example, from 0 to 100 meters, a particular sandstone or any type of hard rock is there. Below that, 1 2 meters or 3 meters of coal seam is there. After that, 2 to 3 meters, another 10 meters or 20 meters, some coal seam is some sandstone is there. Afterwards, any coal seam is there. If there was any uh, if we are removing from surface or top surface or bottom surface, it is termed as multi seam. This multi seam will also have a drastic effect as seam depth. Initially, basically our seam depths are converted into two types: shallow depths and deeper deposits. Shallow depths means which are at a depth of 200 meters, or deeper deposits means which are at a depth of more than 200 to 500 meters. Basically, the amount of the subsidence will be easily detected initially in shallow depths. As we are going to the deeper deposits, the magnitude of subsidence may be higher, but initially the amount will be negligible in deeper deposits. And in with reference to the dip of the seam, comparatively flat seams, the moderately inclined seams will have more amount of more amount of subsidence. With reference to the overburden or different types of roofs, the if at all any weak surface or weak strata is there on the surface of this, but on the surface of the coal, it will immediately tend to fall. So the nature of the overburden or the competence of the roof is it should be a bit high, or else our subsidence phenomenon will be a bit more. And if at all any joint structures or any weak areas, faults or folds, the surface also may tend to have some devastating effects. So the area with less amount of geological disturbances may be best suited for mining activity. If you are having different types of disturbances, the tendency of that particular surface to have subsidence will be a bit more. As well as our with reference to our groundwater, and these things will also have a devastating effect. uh, Basically, with reference to the mining phenomenon, board and pillar and longwall are the coal mining working methods. In board and pillar method, we will okay with kindly consider me. uh, Let us assume this is a horizontal surface. If I'm having a two trees like this, with reference to horizontal displacement, I'm saying, if there was any if there was any vertical displacement, immediately these trees will tend to fall. But in case of horizontal displacement, what will happens means these trees, with reference to this particular location, it may tend to move like this, or it may tend to move like this, or this particular tree also may tend to move like this, and or like this. Actually, the distance between, let us assume the distance between these two things as some some 30 meters, some 30 meters. Because of this sidewise or inside movement or downside movement, what will happen means this particular surface may move inward or move outward. Because of this particular thing, the distance may increase from 30 to 28 meters, let us assume, or 32 meters. Because of this particular thing, the roof, the roots, the base of this particular soil may tend to have a devastating effect, thereby causing disturbance on the whole of the surface. But with reference to our vertical displacement, what will happen means it will slowly move downwards. So, as I told earlier, with reference to the vertical displacement, horizontal displacement, the effect of vertical displacement is visible, but the amount of or the magnitude of horizontal displacement may be light, but the magnitude, as the day progresses, the amount of horizontal displacement may be having devastating effect than vertical displacement. So with reference to this particular thing, as I told earlier, with reference to the surface area on the particular surface of the mine, underground mine, maybe with reference to the how many types of plants are there, how many type of natural habitants are there, they will detect some net present value of that particular surface. In this net present value, they will calculate some example, they will calculate some 1 crore or some 100 rupees. As I told earlier, if our with reference to this particular thing, if the disturbance between these two things will come some, if the disturbance between these two things with reference to the displaced horizontal strain, if it is between 0 to 5 mm per meter, the NVP means net present value, of that particular mine will be some 100 rupees. If at all our particular surface is decreased by 0 to 5 mm, what they will do is they will deduct some 25% of a amount, and if it is between 5 to 10, they will deduct a 50%, and if it is between 10 to 15 mm per meter, they will deduct nearly 75% of the amount. If it is more than 20 mm per meter, they will take whole of the amount. Means what the money you have deposited before starting of the mine in the name of NPV, this particular amount they will give after mine closure. If at all our surface is affected with reference to this particular strain, with reference to these particular values, our the amount which is returned to us will be deducted 25%, 50%, 75%. If it is more than 20 mm per meter, 100% of our amount will be deducted. If more than 20 mm per meter is coming, what they will do means they will simply instruct us to go for the safe workings like partial filling, or in board and pillar methods, means long wall type of workings they will not approve. uh, these particular thing this particular value gave a significant activity. Because of this particular value only, most of the mines, before starting of the mining activity, we have to go for numerical modeling techniques. Any third party, like mostly for mining activity, they will take some major nationalized institutes, education institutes, or our premier research institutes like SIMFO and National Institute of Rock Mechanics. These people are some other colleges. They will approach and they will do a scientific research with reference to the values of this particular ground. They will do some numerical analysis. They have to submit this particular report. With reference to this particular report only, we are getting the permit whether you are going for the longwall panel or board and pillar method with reference to coal mining. So this particular so so this particular net present value, with reference to the Indian Forest Act, gave us uh, Forest Conservation Act gave us the proper justification to do numerical analysis for before starting of the mining activity. Sorry, I came a bit fast here and there. And with reference to these are the factors that influencing these are the factors that are affecting the mine subsidence. And with reference to the with reference to the mining activity, basically with reference to the mining activity, the disturbance will be of three types. First one is the cracks and fissures, are simple cracks that are generated on the surface. Second is the if the disturbance will happen in a short zone or in a small area, then it will be termed as a sinkhole. If the disturbance may tend to have a broader area, like some 100 meters or 200 meters, some 500 meters or 600 meters, or up to an extent of 2 kilometers, 3 kilometers, then it will be termed as a trough subsidence. Basically, these are the three types of subsidence phenomenon that are happened with reference to our mining activity: trough subsidence, sinkhole subsidence, or cracks or fissures. This particular third figure will give you a rough representation of the uh, trough subsidence have happened, and this particular figure will give you a rough representation. This particular figure and this particular figure will give a rough representation of the sinkhole subsidence that is happened over a coal mine. And with reference to these particular horizontal displacement, let us if the intent of this particular vertical displacement between the this particular thing is the opening of that opening width of that particular works. If our display if our displacement is maximum displacement is occurred at a single place, it is termed as critical subsidence. If our displacement is happened at a two place or single place, or if it is happening at two places, it is termed as supercritical. Or if our maximum displacement is not in between this particular width, then it will be termed as subcritical subsidence. Basically, these are the major subsidence prediction methods. In good old days, we used to do the subsidence prediction by theoretical profile influence methods, but as of now, we are going with reference to the numerical modeling techniques. In numerical modeling techniques also, there are these are the subsidence control measures with reference to the different mining activities. Uh, Basically, as most of us know, majorly the numerical simulation techniques are finite element method, finite difference method, boundary element method. With reference to our mining activity, finite element methods, the most suitable softwares which we work are Abacus and ANSYS. And finite difference method, with reference to the finite difference method, the mining software with which we will analyze substance is FLAC 3D or 2D. And with reference to the discrete element method, UDEC is the thing with which will analysis the substance. And with reference to boundary element method, FRAC or BEFI are the elements methods with which we will analysis. But in this particular session, I'm going to give a brief on ANSYS or finite element analysis, with which we have analysis a particular Mainz Mainz subsidence phenomenon. Basically, the the major steps involved in our modeling are data collection, modeling, model geometry, meshing, model material modeling, boundary load conditions are similar. Last one is simulation. In data collection, what we will take is how our model is there. What is the this particular step give us the this particular step will in this particular step we will give what is the density of our with reference to our PMP data, mines PMP data. We will take the what is the density of that particular mine, what is the Young's modulus, what is the bulk modulus, what is the shear modulus, what is the uh, uh, Poisson ratio, what is the tensile strength, shear strength. These particular material properties we will introduce in these uh, particular thing. After giving the elemental properties, we will go for the geometry. In geometry, with reference to the mine's predicted model, what is from surface, what is the depth of the seam, whether our workings is a depth at 100 meters or 200 meters, whether we are having multi seams or single seams. With reference to our mine's geometry, we will take a geometry. In this geometry there are different types of geometry. I have taken a simple geometric thing. After geometry, what we will do is we will mesh this particular model. After meshing of this particular model, initially we gave the material properties. After meshing, before mesh bef- after taking this particular thing, before meshing, we will enhance the material properties to that particular volume. After giving the volumetric positions to the particular thing, we will mesh that particular model. After meshing, we will uh, contrast this particular material, because from surface, Earth's gravity will be acting from in our Earth's crust. Let us assume our surface is y is depth, x is length, uh, lengthwise, z is width direction. Means from y directions, means on surface our earth will be on surface, and downside our our surface will be uh, in the earth. So what we will do is we will fix the bottom face, and remaining faces, means x axis directions, these particular x and z axis, this downward direction, we will fix the surface. And remaining these six faces, what we will do is this particular z axis, z direction, I will constrain the uh, constrain the z direction. In this particular direction, we will constrain the x direction. So if at all any load is acting on this particular surface, our rock surface may tend to move in this direction, so for movement of the particular thing, we will constrain this particular model. After giving these loads, and after fixing the bottom face, we will give the acceleration due to gravity. And after giving these particular things, we will solve this particular model. This is a rough representation of a model that is solved. Uh, After solving this particular model, we will get the displacement curve, the vertical displacement, which vertical displacement of the particular thing. This is a rough representation of means this is not a mine model. We This is a rough representation of that particular model. This is the vertical displacement that has happened there. And this is along the axis, means horizontal direction. This is vertical direction. This is the horizontal strain curves with reference to the particular values. With reference to this particular thing, if we, what we have done is we have made a influence linear function. This is the linear function with reference to that particular model we have made. So I have, as I told earlier, with basically the mines uh, the necessity of the necessity or the importance of subsidence was first detected in India in 1911 by Mr. W. Eng in Zaira coalfields. From 1911, in good olden days, is what the basis is. Uh, substance may be measured with the leveling instruments. As the day progresses, as of now, with reference to our satellite imagery or remote sensing techniques, we are measuring the subsidence phenomenon. But these are the rough data we are taking. But with reference to the mines legislation or mines act, there are some sections, or say there are some rules. They are integrated in our mines act and CMR. These are the section 18, 19, and 22A of our Mines Act have integrated the importance of subsidence in our Mines Act. And with reference to the CMR, this Regulation 123, Regulation 124, and Regulation 126. Means CMR means coal mines regulation. In this regulation 123, 124, and 126 also gave an emphasis on subsidence prediction and monitoring, and mineral conservation and development of rules of 2017. In this particular thing also, rule 23C and rule 34 also gave an emphasis on subsidence phenomenon. As I told earlier, before starting of the mining activity, we have to take some environment clearance. These environment clearance are can be assessed with reference to environment EC clearances. Likewise, we used to say that EC clearance, it is a mixture, it is a combination of the environment impact assessment. In this environment impact assessment and national green tribunal cases also been integrated with our subsidence phenomenon. As I told earlier, for every as the day progresses, most of the mines are integrated with DGMS survey, or in some cases they are taking pilot project that is integrating the daily survey with some server connected in some DGMS office, DMS offices. So some pilot projects they are doing with reference to the particular pilot projects. They are installing some subsidence monitoring stations. These monitoring stations, they will collect the data daily or weekly or monthly. They will take this particular data, and with this particular data, they will take a rough report. This report is checked with reference to the report that is generated by the mining people. If there was any deviation in this particular thing, deviation in these things, the mining people have to answer what is the difference between the integrated data which you are getting and the data from which we are taking. So as the day progresses, the importance of substance is gone increasing. Okay. Uh, Thank you for giving me this opportunity. I hope I have somewhere gave a rough data on substance. Sorry, is my PPT is not visible? I hope in the comments some are saying the PPT is not visible. Sir will give you these PPTs. I think.
Yes, sir. Thank you, sir. Thank you for the wonderful session, sir. Audience, if you have any doubt or any clarification, now the forum is open for doubt clearance. So you can ask your doubts directly to our chief guest. Okay, audience, if no doubts, we can move on to next agenda. Um, Sir will once Sir will share the PPT, we will share it to all the members. Thank you for your patient listening. So please fill up today's feedback form also. Good evening to 1.5% for today's session. It is my privilege and pleasant duty to deliver the vote of thanks on behalf of IEI Salem Local Center as we concluded this enriching 77th session webinar of our of our engineers talk series under Managing Division Board. First and foremost, I extend our deepest gratitude to our esteemed today's chief guest and keynote speaker, Engineer Chitti Ravikiran sir. Sir, your enlightening presentation on the theme has provided our participants with deep technical insights. Uh, Also, we get some practical perspectives and new again appreciation for the complex challenges and solutions in mining and geotechnical engineering. We are truly grateful to your time and effort, sir. Thank you, sir. I also take this opportunity to thank all our participants, members of IEI, fellow engineers, faculty, researchers, and students for joining us from different parts. Your enthusiastic presence and engagement give meaning to this platform and inspire us to keep striving for excellence. Also, I want to especially thank one person, none other than our friend engineer Sornay sir for giving again content of our today's speaker and also continuously actually sir is giving support to our all activities. So I would
Thank
like
you.
to thank you, sir. Thank our technical team and also our IE SLC office staff engineer T. Tiago and everyone who worked behind these again scenes to ensure the smooth conduct of this webinar. Last but not least, I thank the Institution of Engineers headquarters and also the Mining Division Board, which has been serving the nation for over a century, for providing us with the prestigious platform to bring together engineering minds in service of society. Let us continue to learn, collaborate, and contribute to the growth of our profession and also our country. Thank you once again and have a wonderful weekend. Thank you. Thank you all. Ravikiran sir, thanks a lot, sir, for